All right, everyone. Well, good afternoon, and I might make a start. So, welcome to the last session of the last day of the last conference for this week. And for those of you watching live, well done. It's been a very long week. They've been very rewarding, though. So, hopefully, you've enjoyed your week with VMworld and also our CodeCon. So my name is Mark Foley. I'm a Senior Systems Engineer with VMware, and I'm based here in Brisbane, Australia. So due to some stunning lack of organisation on my part, I'm actually presenting to you early on Saturday morning. So if you hear a loud noise, that's one of my teenage daughters either getting up or coming home. I'm never sure which. So today's session's on distributed tracing, and it's derived off a session I've done a couple of times in the past, but it's a little bit of a longer look at distributed tracing and just going a little bit deeper into a more real-world application of it. So what we're going to cover today is I'm going to look at the basics of distributed tracing, so why you might want to use it, what it is, and also go through a basic demonstration of distributed tracing in a sample application, so instruments and code, and look at the output we get out of it. And then look at some of just the challenges of distributed tracing and how we might go about addressing some of those challenges in a real-world application. So I've got another example of a more real-world application and more real-world setup of distributed tracing. And then the last thing I want to do is look at the combination of distributed tracing and metrics. So the platform we're going to be using today is actually a VMware platform. It's called Tanzu Observability. And one of the really nice and unique things it does is it brings together the world of tracing and metrics. So I'm going to cover that last, and just rest assured, if you're not using Tanzu Observability, but you still want to get into distributed tracing, most of what I'm going to cover today is applicable to any distributed tracing system, particularly those that are open tracing or compliant. So what we're going to do is, let's just go in here and just talk about why you might want to use distributed tracing. So traditionally, there's two real drivers for distributed tracing, and just going from right to left on the slide there. The first is around optimizing application performance. So being able to find any bottlenecks in your application and then understanding why those bottlenecks are occurring and then fixing them and being able to verify that those bottlenecks have actually been addressed. Secondly, we want to be able to troubleshoot faster. So not just performance issues, but any type of application error or bug in your code. Just the visibility you get out of distributed tracing is going to allow you to get a much better understanding of what's going on and be able to quickly identify a problem. And then the last thing around distributed tracing, particularly in the world of Tanzu Observability, is this combination of tracing and metrics is going to allow you to do to easily set up some more general purpose monitoring of your application. And as I said earlier, we're going to cover that last of all today.
Hey, Mark, I got to interrupt you for just a second and ask a real quick question.
Sure.
On your slide, it says confidential VMware Inc. Is that just a bug?
No, that is just a bug. Sorry about that.
Just want to confirm that that's the case so everybody can know that. Thank you.
Yeah, no problems, Eric. Thanks. Okay. So what I want to do first is just cover off what a trace actually is in distributed tracing. So a trace is made up of at least one span, and generally a trace will be made up of multiple spans. So what's a span? If you look on the slide here, what you'll see is I have a very, very simple Python function here called parent. And parent just simply does one thing, it calls another function called child. Now, if I were to instrument this function for distributed tracing, every time I invoke this function, what's going to be created is a trace. And as I say, that trace will have a span. And the span associated with this function will generally be called parent. By convention, when we create a span, we will give the span the name of the function. Now, the parent span has a few attributes that we're interested in. Obviously, the name. It will also have a start time, so when this function was invoked, and also a duration, so how long it took to run. So it's fairly simple data structure, but we can actually build that up and decorate it. So we can add a whole bunch of other pieces of information to that if we choose. So they're called tags, and we're going to see some examples of tags later on. The other thing we can do is really a span is not really giving us any insight into what is happening inside the function. So for a particular complex or long-running function, we might want to know when certain events happened inside the function. And for that, we use a log. And again, I'm going to give you an example of a log in a minute. So that is a very simple trace with one span. However, in the real world, most of our traces are made up of multiple spans. So our parent function is going to call a function called child. And what's going to happen is, again, if we were to instrument that child function, a span would be created. Because parent called child, we want to reflect that parent-child relationship in the trace. So what's going to happen is when we create the child span, it'll have all the same information, all the attributes we expect for a span, but also what will be captured is that parent-child relationship and the offset. So the duration or the length of time between when the parent span started and the child span started. And these parent-child relationships can be repeated as deep as you need to go. And in a complex piece of software, these traces can actually get very, very large. The other thing I just want to make you aware of is that, it's called distributed tracing, and most of our applications these days aren't running in a single process. They're on multiple processes or even multiple machines. So when we start making calls across networks between clients and servers, one of the things we want to do is be able to propagate span context. So we want to be able to see that full trace across all the different components, regardless of where they are. So we need to also be able to take into account network calls. And again, an example I am going to give you, we're going to look at exactly how we do that. So what I want to do is give you a demonstration of distributed tracing now, and we're going to use something called direct ingestion. So we are basically going to instrument our code, and we're going to forward our traces to Tanzu Observability, which is a SaaS service. So all this stuff is going to be pushed out into our Tanzu SaaS service. We're going to do manual instrumentation, so we need to manually instrument our code, and we're also going to cover off the network propagation. So how do we handle that scenario where a client is calling a server component? So what I have here is a really simple application that effectively does nothing. There really is no functionality in here at all. It's just a client component. That client component calls into a server component, which happens to be hosted on the Kubernetes cluster, and that server component calls a number of other server components. So it really just illustrates the various hops between these different components. Now, if we're going to use distributed tracing, one of the first things, or the first thing we need to do is actually set up or configure our distributed tracing environment. And ultimately, regardless of whether we're using Tanzu Observability or Jaeger or Zipkin or any of the other open tracing compliant implementations, what we want to do is create a tracer object, which is this thing here, the tracer. Generally, the tracer will be left in your code as a global object, and that is how we get access to all the various distributed tracing services. Because we're using Tanzu Observability, there's a few Tanzu Observability specific steps we need to take into account. And at this point, I want to give you a little bit of a heads up. Tanzu Observability is not the full name of our product. It's actually called Tanzu Observability by Wavefront. And all the capabilities of that product come out of an acquisition VMware did a couple of years ago of a company called Wavefront. So what you'll notice is that in the SDK in particular, we still have a lot of references to Wavefront. So apologies in advance, but I'm going to probably interchangeably talk about Wavefront and Tanzu Observability. So what are some of the setup things that we need to do? Because this is a SaaS service, we don't want just anyone pushing data into it. So what we have here is our token that defines which Wavefront service that this data is going into, as well as a security token. So unless I have that token, then I'm not going to be able to push data into Wavefront. The other thing we have here is an application tag. So because Tanzu Observability is a SaaS service and most organizations will only have one instance of it, you could have tens, hundreds, or even thousands of different applications push and trace data into it. So we will need to be able to have some way of distinguishing between the different applications and the different services. And the way we do that is with these application tags. So in this case, my application is called VMware 2020 Demo, and the service is called Truck. Now this VMware 2020 Demo has a number of services, and each service has a different name. And you'll see later that's going to allow me to slice and dice and be able to find the traces that are of interest to me. So that's setup, right? And this setup is going to be fairly similar regardless of the distributed tracing implementation you use. And later on, I'll show you a Jaeger setup, and you'll see it's actually quite similar. Ultimately, though, we want the tracer object. Okay, so we're ready to go, right? Now we're able to create traces and send them into Tanzu Observability. So let's have a look here at what we've got. I have a few different methods here that we want to, oops, go through. Okay, so this is the method I'm going to start with, send performance data. It's an entry point, right? So this particular service is just a command line application running on my PC, and it has 2 or 3 major functions. And generally what we want to do is we want to put traces around our key functions of interest, or any functions we think might have performance implication. What you're going to see here is I've actually implemented tracing on 3 functions that each of those do very little. It's probably not something you'd do in the real world. You'd be a little more selective about what you would trace. And as I say, usually it's the major entry points or exit points, or those areas you think might be performance sensitive. So what I've done here is I have instrumented this function. So I have the reference to our tracer object, which, as I said earlier, normally just left as a global, and I have said start active span, which is going to tell Tanzu Observability to start a new span. That start active span is going to return a reference to a scope object. And a scope object is something that is maintained by our distributed tracing implementation. And again, it's a global, but it's a thread global. So each thread will have its own scope, and the scope keeps track of whether there is or not there is an active trace running in that thread, and also just what that active trace is and what the active span is. Now, in this case, because it's my entry point, there's no active trace. So when I start the span, a brand new trace will be created. The other thing you'll notice here is once I get the reference to that scope, I'm able to basically create log events, which are these before and after work events that I've created. And as I said earlier, that's going to give us insight into what is happening inside the function. So that's it, right? That is enough. That's all you need to do to go and create a space and report a span into Tanzu Observability. So let's have a look at what that looks like in Tanzu Observability. So here I have a view from Tanzu Observability, and I am looking at a specific instance of a trace for that send performance data function. And what you can see here is we have the service name, which is truck, we have the function name, and what we can do is we can expand that out and see all the various tags associated with it. We can see here that the invocation took 2 seconds. We also have the start time and some other tags that are automatically associated with that particular trace instance. Also down the bottom here, we have the logs. So you'll notice that the logs, we have the text that we create, where we specify when we created those log events, but also the offset. So the before work event occurred 22 milliseconds after the start of the send performance data function. So that's it. That is a very simple trace with a single span associated with it. But actually, there's a little bit more to this trace and the span. Let's go back to the code and see what else is happening there. So in my code there, you'll notice that the send performance data calls gather performance data. And again, that is instrumented as well. So again, we've said start a new span. Now, because the scope object knows there's already a trace running, and it knows that there's already a existing span in that trace, it is going to automatically create a parent-child relationship between the span I created here and the one that's already running in the send performance data method. And we can see that here. If we expand out, we can see send performance data calls gather performance data. We have the duration for gather performance data. We should also have an offset, but because it was called literally right after the start of the send performance data, the offset's not really visible to us. And then also we have the full call tree for this particular invocation. So that's interesting. But what happens down the bottom here when we actually start to come out of the truck service and we call the truck collector service, the data aggregator service, and so on and so forth? We're actually making calls across network boundaries to server components. So something else needs to happen there, because the trace objects and the scope objects, they are only available within our process and the threads that we're interested in. So there's automatic creation of the parent-child relationships. It's not going to work anymore. So there's some more work to do when we want to make a call across a network boundary. And what's actually happening, you can see down here in our push performance data method. So the line of interest is this one here, the tracer inject. And what inject does is we will pass in some sort of data structure, and inject will put into that data structure an identifier for the span. So this span here has an identifier associated with it. Inject takes that identifier and puts it into our data structure. And in this case, our data structure is HTTP header that's going to be passed when we make the REST call to that server component. So fairly simple, but there's a little bit of work to do, but we absolutely have to pass that data structure across. Otherwise, on the server side, we're not going to be able to create that parent-child relationship between the traces. Then when we get to the server side, so on the truck collector, we need to extract that data structure. So you'll see here the tracer extract method, and that's going to give us what we call a span context. And then when we start the span on the server side, we need to pass in this additional parameter, which is that identifier. And all of that is going to enable Tanzu Observability to pull together all these parent-child relationships for our truck collector, and all the other components that are sitting in there. So that's how we get this full view across all of the different components in our application. So that's great. And as I say, this is a single trace from a single method invocation. Let's have a look at some of the other capabilities that you get in terms of observability to view and manipulate trace information. So as you can see here, we have the tracer screen, the main tracer screen. We are able to specify a time period that we're interested in. So if you come in the morning and someone says, hey, there was an incident at 11 o'clock last night, you're able to go to that period and see what was happening there. We're also able to do some sorting. So we can say, hey, let's look at the outliers. So let's look at the traces that took way longer or way less time than others. And you'll notice here, associated with each trace is a percentile. So this particular instance of send performance data took 3.4 seconds, which is on the 99th percentile for all of the other calls. So that might be something we want to have a look at. And indeed, what you can see there is actually an error occurred in that invocation. So again, we're able to say, hey, just show us the errors, or just show us the longest traces, the shortest, the ones with the most spans, the least spans. It's a really good way to slice dice. Additionally, we're able to do filtering. So what we can do is filter by the operation that we're interested in. So go and select a specific operation, or we're able to, actually let's go in there and I have to select one, or we're able to filter on tags. So one of the things that I haven't shown you in code is you're able to put your own tag next to or associated with a span. And also what we're going to do is automatically put a whole bunch of other tags there. So again, it allows us to slice, dice, and drill down into the area of interest. The other two things I just want to call out here on Tanzu Observability is the service map. So this is something that's really, really useful with distributed tracing. Most of the implementations will give you a similar capability. Because Tanzu Observability is looking, understands which service talks to which other services, it's able to draw the service map. So this map is showing you the relationship between all the different components involved in this particular trace, as well as the dependencies between them. And so we'll automatically build this information up as we're monitoring the application. The other thing we see here are just some overall metrics about this particular function in general. So every time we see a SEM performance data trace, we extract all these metrics, and we're basically gathering all this summary information. So you can see here, I can see the error percentage over the last 2 hours, or I can look at it, say, over the last 6 hours. The duration, so the average duration of these calls, and also the rate of requests per minute. And later on today, we'll have a look in more detail at some of the metrics capabilities in there. So that is a simple demonstration of tracing, and then some of the visibility you get in that trace data in Tanzu Observability. So let's just go back to the presentation for a little bit and talk about some of the issues that you might have seen in there. And also a few issues you might not be aware of. So the first one I want to talk about is implementation capabilities. So Tanzu Observability implements the Open Tracing API. So Open Tracing is just trying to standardize the programming interfaces that you use to communicate with a distributed tracing implementation. It's not a standard. So if you have one component that, say, uses Jaeger and another component that uses Tanzu Observability, then there's no interoperability between them. If you've got a very large organization and maybe some teams have done some work with Jaeger, some other teams have done some work with Zipkin, but you want to use Tanzu Observability, that can be a little bit of a problem. So there's things we can do in Tanzu Observability that can help you there, but that, unfortunately, they don't fully address the problem. You're never going to be able to have a trace that goes from a Zipkin instrumented component to a Jaeger instrumented component and be able to stitch it all together. You really want to be having all of the traces in your application using the same tool set. The other thing is network overhead. So those traces aren't that large, but there's a lot of them, and particularly with a SaaS service like Tanzu Observability, you don't necessarily want to be sending all of those into your service. So there's possibly some filtering that we might want to do. And in that really simple application I showed you, there's no filtering going on at all. So we probably want to do something about that. Other challenges, this decentralized configuration. So, things like the wavefront token, or if we wanted to implement some filtering on our tracing, we've got a large application with lots of services. You saw earlier, I have to do that configuration in each individual service. And I'm sure, I can probably use a configuration file or something like that to get around that, but that introduces its own problems. Not least of all, I'm going to have to restart the services for the configuration file changes to take effect. So I probably want a better mechanism to configure distributed tracing. And the last thing I want to talk about is this code clutter. As you saw, that implementing distributed tracing application using manual instrumentation, which is what I just showed you, it's pretty intrusive, right? Everything that's traced is going to have these start and stop tracing in there. You're going to be log messages in there. You're going to be adding tags. It's not that great, and it's just one more thing you need to think of, and potentially one more thing to go wrong. So ideally, we'd want some way of instrumenting without actually having to write code. So let's go through these things one by one. So I'm going to look at a slightly different application. Again, this is a Kubernetes application. It's a web application. There's a couple of components there, as well as a MySQL database, and it also calls out to a third-party web service. And I'm not really going to worry too much about what the application does. A little more functionality than the last one, though. I'm going to implement tracing on this application, but instead of doing direct ingestion, where each service sends data directly into the Wavefront SaaS service, I'm going to have these services send the data to a proxy, so a Wavefront proxy. And what that means is all my configuration can be isolated into the proxy, and it's also better from a security point of view. We've only got one component in our environment pushing data into the SaaS service. Also, because this particular team started out using Jaeger, I don't want to go and make them change their code and have to modify their instrumentation. So what I'm going to do is use a nice feature of Tanzu Observability where it is compatible with things like Jaeger and Zipkin. So what I'm able to do is leave the Jaeger instrumentation in place, have these forward the traces to a Jaeger agent, and then just have that Jaeger agent forward the traces to the wavefront proxy, which is then going to push everything into Tanzu Observability. So this is probably going to address a couple of things. So security concerns, it's also going to address the centralized configuration. And lastly, as you'll see, it's also going to help us with the issue of network overhead. So let's have a look at what this looks like. So I'm just going to go back into my application. I'm going to use another VMware open source tool called Octane to have a look on my Kubernetes cluster. So you see here, I'm in my plain spotter namespace, and I have all my application components. So a couple of instances of my front end, my application server, but also I have my Jaeger agent and my wavefront proxy deployed in here. And so everything's pushing first into Jaeger and then into wavefront. Now let's have a look at how that wavefront proxy is configured. Now we're going to go into here and just change to a different application. Right, so here's the YAML file, which has all the configuration settings for that proxy. So the first thing you notice is that things like the location of the wavefront service and the token, it's in the proxy, so that no longer has to be in each individual service. We're also able to specify a whole bunch of arguments, and in this case, most of these arguments here are telling the wavefront proxy to be compatible with Zipkin and Jaeger. So we had to go and set that up for this to work. There's a few other interesting settings that I haven't actually turned on, but you probably need to be aware of. We have what we call the trace sampling rate. So at the moment, we're using the default, which is 100%. So what this means is every single trace received by the proxy is going to be forwarded into the SaaS service. If I made that 15 or 10%, which is what I usually leave it at, it's going to randomly select 10% of the traces and forward that to the proxy service. Now, that's quite a good thing to do because it decreases the overhead, lowers the amount of network traffic that you've got there. But what it means is by just taking 10% of those traces, I have a baseline. So I know what normal operations looks like. And then in the case of an issue or some sort of performance event, what I'm able to do is then increase that sampling rate to a higher value. So I'm seeing more of those traces and able to compare that to my baseline. So it's quite a nice feature, and I would usually have that at less than 100%. The other thing that we've got here is, the trace sampling duration. So this is now set at 0, which means regardless, wavefront, the proxy is just going to ignore how long each trace takes. If we set that to a non-zero value, that will be that'll represent a certain number of milliseconds. So I often set that to say a total of 5 seconds. And what that means is that any trace that takes more than 5 seconds will automatically be reported. So regardless of whether sampling is turned on or not. So it means that anything long running, which you're probably going to be interested in knowing about, is automatically going to show up in the Tanzu Observability, and you're going to be able to analyze that. So that's often a useful one to turn on as well. The other one here is always sample errors. And what if we set that to true, then any trace with the error flag triggered on it is automatically again going to be forwarded to wavefront proxy. So this combination of settings means that you can have a fairly low percentage of traces being forwarded to Tanzu Observability, and it's going to allow you to get a baseline and just keep an eye on the performance. But in the case of any unusual events like a really long-running operation or an error, that will automatically be forwarded. So in a production system, I would always have these values turned on. And the fact that we're using the proxy means we only need to turn them on in the one location. So let's say it's a really good way of doing things. The last thing I want to cover off that I call out as being potentially an issue is that of code clutter. So we saw earlier in the example I gave before of having to manually code the creation of traces and spans in our code base, and that can be a bit of work. Usually you don't have to do that. So let's have a look at this particular application again, and I'm going to look at the front end of it. So you'll notice that we again have something fairly similar, which is our setup for our tracing. So, and notice, even though we're using a different implementation, in this case Jaeger, it actually looks fairly similar, right? We have some configuration, and then we're creating a tracer, and that again is a global object that we can use to access all the various services of Tanzu Observability. Now, in Python, one of the things we're able to do is we are able to use a library, which is called the Open Tracing Instrumentation library. And what that has done, what that particular library does, is it allows us to automatically instrument a number of commonly used Python frameworks. So in this case, this particular application is built on the Flask framework. We use SQL Alchemy for talking to databases, and we use the request framework for making REST calls. All of those frameworks are actually handled by the Open Tracing Instrumentation library. So all we need to do is make this particular call here, install all patches. I have no idea why the function is called that, but that's just what the designers called it. Call install all patches, and that will automatically instrument everything in this particular application. So all of the Flask entry points, so there's all of our web pages and API entry points, all of our calls to our SQL database, as well as all of our remote procedure calls. It will do all of the context propagation for us as well. All of that's done for us, and that will work with any open tracing compliant implementation. So as in this case, we're using Jaeger. We could have been using the Tanzu Observability libraries as well. It doesn't matter. Most programming language, I think actually all of them that I'm familiar with, have this form of automated instrumentation. So in general, that concern of code clutter shouldn't be an issue. But what you're going to probably need to do is a little bit of research into the programming language or the frameworks that you're using, and just understand what your options are for automated configuration. The other thing to be aware of is this particular method, it's a bit of a blunt instrument, right? It's going to instrument everything. Now, you might not want to do that. You might want to be a little bit more selective. And again, this Open Tracing Instrumentation library does give you a few mechanisms to be more selective about what you instrument. So let's say I have had to do nothing at all there. If I go through my code base, you're not going to see any calls to the tracer object at all. You're not going to see any packaging up of span context. None of that's going to be occurring in here. You're still going to get that tracing information. So let's have a look in Tanzu Observability and see what that looks like. So back in here, and in this case, what I'm going to do is change the application that I'm looking at. Let's get rid of that. Right. And there you see the trace data from that PlaneSpotter application. Now, if I click on the details, which is probably one of the more complex invocations there, you can see this is where the details web page is invoked. You'll see here there's a call from the front end to the application server, and then the application server is making a whole bunch of SQL queries. As part of the automated instrumentation, the other thing that's happened is we also get a whole lot of additional tags. So you can see in here, for instance, the Open Tracing Instrumentation Framework has added the URL, the HTTP status code from this particular web page, automatically added. So if you wanted to do a search for, say, HTTP status code 400 or 500, well, because it's a tag, then you're actually able to do that. So it's a nice little usability enhancement. If we go down here to the instrumentation of the SQL Alchemy framework and all those SQL calls that are there, if I click on the SQL select statement and I expand out the tags, I can actually see the SQL statement that was sent to our database. So that's a great example of how with really very little effort at all, so literally 5 lines of code, setting up of a proxy, you get this incredible visibility into your application. So if you get a bug or some sort of performance issue, all this stuff's going to be available to you, and it's going to be really, really useful in understanding why that's occurring and fixing it. So to me, that's a really good demonstration of why you should be looking at distributed tracing and just how easy it can be used once you're familiar with it. So I'll just get back to the presentation now. And the last thing I want to cover off today is the concept of distributed tracing and metrics. So, today I've shown you distributed tracing, and that's more to dive deep on an issue and get some context on a problem that you're experiencing. So, a lot of the time, you're not going to be looking at that trace information until you need it. Tanzu Observability is primarily a metrics engine, so it's more of a general purpose monitoring solution that is based on metrics. So effectively what Tanzu Observability, the more commonly used mode of using it is have our application or our infrastructure send metrics into Tanzu Observability. We then use those metrics to build dashboards, which allow us to monitor our environment, and also we can do things like alerting, correlation, all the sort of stuff you expect to see in a monitoring system. So it's more, what is our application doing? How well is it servicing our users? And just allowing us to identify when we do have a problem. Then when we have a problem, we'll dive into the traces. So almost two separate worlds. One of the really nice and unique things about Tanzu Observability is it actually brings together these world of tracing and metrics. And what it will do is it will automatically generate metric information from the trace data. And that's very, very helpful, because what it means is if you implement tracing, you automatically get metrics. And as you've just seen earlier, tracing is pretty easy to implement in your application. If we wanted to do metrics standalone, then potentially that's more code that will need to go into our environment. Whereas just by doing the tracing, we automatically generate the metrics, and they're actually really, really good metrics that give us really great insight into our application. But let's have a look at what this looks like in Tanzu Observability. So we go back into the Tanzu Observability, and you'll notice this application area. This is where all of our trace data is available. One of the things we have is what we call a service dashboard. And the service dashboard is a first look at the metrics that are generated from this trace information. So what you see here is this is the service dashboard for the data aggregator service. And notice that we can further drill down, and if we've got multiple instances of that service, or we want to look at a particular span, or only look at errors, well, fine, we can do all that with these drop downs at the top. I just want a general purpose view. And effectively what we're looking at here are what are called red metrics. So red stands for rate. So in this case, the number of requests per second on the service. Errors, so the percentage, in this case, the percentage of requests that result in an error. And also duration, so the duration of calls made to this particular service. And these metrics, as I said, are automatically generated from the trace data that we send through to Tanzu Observability. And you notice this dashboard is quite nice, right? So it's got, say, the requests per second, what are the most commonly called functions on our service. If I actually make this a bit bigger, we should see some errors. Oh, not yet. No, actually, let's pick a service that I know has some errors. Yeah, there we go. So here we had a few instances of errors over the last couple of hours. So 1% of the requests resulted in errors, and where are the errors coming from? Well, they're coming from push performance data. And if I click on that, it'll actually drill through to those traces. So As you can see, these metrics provide you with a good overview. You might have a screen like this running more regularly, and then as things change, then you might go and drill into the trace data. Now, this is good, but this particular view is not really what I want. And the issue is, for me, is that this is just looking at, this only allows us to look at a service at a time. I want a more global view of my application. And the way I can do that in terms of observability is build my own dashboard. And I've actually started doing one. So let's have a look at this. So I have a truck dashboard that I've started building. And what I want to do here is drill down into that and edit it. Okay, so let's have a look here. Sorry about this. I should have made these changes earlier. But I just want to show you how we build up a dashboard in Tanzu Observability using those metrics. Oops. So let's turn a couple of these time series off. So what we're looking at here is time series data, and this is what the TS indicates. And we basically provide a metric name. So in this case, tracing.derived means all those metrics that are derived from our tracing data. And then you see our application tag, and also we can go down and put in our service tag if we want to as well. So in my demo, I'm going to look at the truck collector, and I want to look at a specific API and the count of invocations. And there we go, right? So we have a metric for that particular method, and we can now have a that metric is the count, right? So the total number of calls made against that method at any particular point in time. As you saw earlier, we're also able to use wildcards. So I can replace this and basically say, hey, I want to see all of the different invocations for the truck collector. So when I hover the mouse over here, I can see in the tooltip the different what the different lines represent. So here I'm seeing all of the methods that are invoked in truck collector. And again, I can extend that wildcard and make it a little bit bigger. So now I'm looking at every single instrumented method in the entire application. And I have a line for each of those. So that's a metric, right? But to me, that's not that useful, because this is what we call a count. So what will happen is this is in Tanzu Observability, this kind of data is called this kind of metric called a counter. So it increments over time. So what you're seeing is at this particular point in time, 7:45, this is the total number of times that each of these functions has been called since we started monitoring. I don't want that. I actually want to see the rate, so the number of requests per minute or per second. And the way I can do that is just apply another function and change it to rate, right? And that function's automatically applied, and now instead of a count, I'm looking at the rate of requests being made against that particular service. So that's great, right? And that means that I now can see the rate, but it's still a bit noisy. So I've got all these different lines representing every single service that my application provides. As I said earlier, I want a more aggregate view. So the way I can do that is just wrap the whole thing in a sum. And done, right? So now I have a single time series that just shows me the total number of the invocations per second against my application at any particular point in time. So that's a good start for a global dashboard, and now we want to build it up with a couple of other different things as well. I'm also interested in how long these requests take. So if I just go and uncheck this and check this one, similar sort of thing here, right? So we've got now, we have the duration of the calls in microseconds. And again, the same thing happening, right? We've got it for each individual method, because we have used the wildcard to basically say, I want the duration for all of the components and all of the services provided by each components. I've also said, show me the 95th percentile. So the number that you see there is the duration at which 95% of the calls were either at or below. That's usually using percentage or averages is the best way to look at this duration data. Again, same thing, right? I want to aggregate this data. Now, it probably wouldn't make sense to sum it all up. So in this case, what I'm going to do is do an average. Right, so now I've got the average duration for these particular calls. So for all the calls in my application, and I can now add the 2 lines there, and what you'll see here is I now have the number of requests per second and the duration of calls. And then finally, the last thing I want to add into this is errors, right? So the incidence of errors. And what you're seeing here is actually a pretty clear pattern, right? So if I sort of put the mouse over this little bit here, duration is in blue. And you'll notice that when we get a spike in duration, which is the blue line, we also get a spike in the green line, which in this case happens to be the error count. Even though the number of requests per second of our application hasn't changed. So there seems to be something going on in my application, and that's associated with longer processing times for our services. So one of the things I might want to do, if I want to be proactive and get an alert when it looks like we might start getting some errors occurring, is I can actually go in here and say, create an alert based off the duration. And this is going to allow me to specify an expression and define an alert and how I'm going to be notified of that. So that's a useful thing to be able to do. And in a production environment, I might well do that. The other thing I'm able to do, let me just save this. So this is now my dashboard, my sort of global dashboard for the application. Very simple, but it's given me a lot of interesting information. And then in a circumstance like this, where I do detect an issue, what I'm able to do is select the time period of concern, drill down on it, and then, okay, well, that's interesting. Maybe I want to drill down and go and look at that trace information for the particular components contributing to that. So I can go in there and look at my traces and notice what's happened, right? It's automatically looking specify the same time period I was looking at in the graph, and then what I'm able to do is go through and say, hey, let's go and find the errors or those areas of concern. So all of that monitoring and visibility that you just saw, the ability to create alerts, drill through graphs, all of that stuff was you're able to do that just by virtue of the fact that you've enabled tracing. So that's all you needed to do, turn on tracing. As you saw earlier, turning on tracing doesn't need to be too much overhead associated with it. We can simply automatically instrument our code, and we're done. So that doesn't take a lot of effort to get some great observability into your application, and that's really the power of Tanzu Observability. So that's really the end of what I wanted to cover today. So just to yeah, so look, thank you very much. I say, just to summarize that, most of that presentation was concerned with tracing, and I use Tanzu Observability for tracing, and as you saw towards the end, there's a lot of benefits of Tanzu Observability in terms of bringing together the metrics and the tracing world. However, you don't need to go down that path if you don't want to. There are open source frameworks like Jaeger, which is a very good way to get into distributed tracing. And a lot of that functionality in terms of the troubleshooting, being able to drill in, look at your traces, understand where the performance bottlenecks or issues are, that's equally available to you in something like Jaeger. So I say, if you're managing applications, you're writing applications, and you need to support those, then distributed tracing is really something that you should be looking at. Thank you very much for attending today. I don't see any questions on the Q&A or the chat, so I think we'll probably wrap it up at this time. I noticed that Julia's put a message out there that if you could fill in the survey, that'd be much appreciated. Thank you very much. Thank you for attending. I hope you enjoyed the CodeCon conference, and with any luck, we will see you next year. Thank you very much, and goodbye.
Thank you. Bye.